In homework 2, we will be looking at functions that do not necessarily pass a vertical line test as well as a horizontal line test. So therefore, if they don't pass a horizontal line test, they will not be a function. In the first one, you have an absolute value. Your absolute value has 2 branches to it. It will not pass a horizontal line test. So we have to restrict the domain, find the minimum point right here, locate its minimum through your calculator, and restrict the domain. In this case, we want the increasing part. So our domain will be from 1.5 to infinity. Our range doesn't change because it's from 0 to infinity. And you'll just be working with the one leg of this. Find your domain and range and watch how these interchange when you find your inverse. To find your inverse, use the same concept. xy interchanges to yx. Interchange them and then use your function notation at the end to put out your new inverse function. Now you can check this in your calculator and you notice that this creates a line. This line will continue all the way through here. So you'll need to limit that domain to the domain from 0 to infinity of its inverse function. Otherwise, it's going to include the rest of that line, and you don't want that piece over here. In the second example, we have a radical. A radical has its own domain restriction. So we take the radical out, set it greater than or equal to 0, and you can see your domain goes from 5/2 to 0, to infinity. Now that point is really important. This is your 5/2, 0 point. If you interchange this point, it becomes this one, 0, 5/2. And you can almost see that this will be a reflection over the line y equals x. Interchange your x and y. To get rid of a radical, we square both sides. And when you come down here, you're going to notice that that's a parabola. This red one will actually give you the parabola, and you do not want that part. So you're going to have to limit your domain to say 0 to infinity. It is the reverse of the range from the original function. Number 3 and 4, we want the decreasing parts. In number 3, there's your parabola. And if you remember your transformations, it's 4 horizontal to the left units. So your parabola would look like this. Going 4 to the left puts that vertex point at -4, 0. Now we want its decreasing side. So you're going to cut it off here, and you've got a domain of -infinity to -4. And your range, again, is from 0 to infinity. When you interchange those, the range from your original function becomes the domain of your inverse. The domain becomes its range. Again, swap out the x and the y, and when you square root, you get a positive and negative. In this case, because we want the decreasing, we use the negative function. Rewrite it, and you'll see this makes its own domain, the radical x. It makes its own domain, and it is the same domain that we wanted when we switched out the range and the domain. So graph the little piece here, and you can see that it's a reflection over the y equals x. In this last example, even though this is raised to the 4th power, it behaves like a parabola. So when you graph it, you'll be looking at a kind of a parabola. Find its minimum, and you will find the point to be 3, 2. If you swap that out, 2, 3, that'll help you graph the inverse of it. Interchange the x and the y and solve for y. In taking a square, you took a square root. In taking a fourth, you take a fourth root. Fourth roots and square roots behave the same way. They both get a positive and a negative. And in this case, we want the decreasing, so use the negative. And that in itself makes its own domain. Your domain becomes the range, your range becomes the domain. And then graph that little part. If you put it in your calculator, you could take the original one and swap the table. Remember, every time you do a reflection over the y equals x, all the xy's interchange to yx. The domain, the range, the x, the y in the tables of the graph, the x, the y in the equations. Everything will swap.